Hi, so we are getting started with our session on financial machine learning. In the house, I'm glad to bring Mr. Divyam Sharma, who is an intern at Hackveda on quantitative finance on financial machine learning. Mr. Divyam is a student of economics and mathematics at Indian Institute of Technology, Kharagpur. And during his interns, he has made implementations of various scripts on financial data. He's working on GIM, OpenAI. He's working on QTrader, that is an automated for trading project. Followed by, he has got various scripts related to quantitative finance, which he will be discussing with you guys today. So I hope you all are going to have a fantastic session, followed by the scripts and everything, whatever we will be conducting will be available on our website, hackveda.in. So what you guys can do, you can reach out to us on our website, hackveda.in, and talk to mentor. And depending on identification of your objectives, our mentors will help you out with machine learning and finance. So over to you, Divya.
Okay, good evening, guys. So as sir told, my name is Divyam Sharma and I'm a second year undergraduate student at IIT Kharagpur. I'm here as a financial machine learning intern with Hackveda. And today we'll be learning how we can query data, real-time market data from the finance industry, and how we can apply data science and machine learning algorithms on it using one of the latest interfaces that is present on the internet today. We will be using quantopian.org and research notebooks from the same as well for our purpose, because our research says that this is one of the latest and the most handy tools and a tool of the future. So let me get started with this introduction, and I'll share my screen with you so that you guys can view the code that we will be writing. So this session is going to be a real-time coding project. All right, so let's start. So how you can access quantopian.org is that you type quantopian.org on your terminals. And I have already done that, so I'll show it to you guys.
We can have a notepad wherein all the links can be segregated so that people will get it.
Okay.
So you can have a notepad file with some high font size so that people will be able to observe it a little big. Yeah, that is like nice.
So let's log into quantopian.org. I've already logged into quantopian.org, but let me show you how to reach this interface for your own notebook. For a new notebook, you can click on that to get a notebook for yourself. All right, so you can either run a cell by pressing Shift Enter, or you can use the play button that is there. You can find it here in the middle of your screen, top middle of your screen. You can find the run button, and which is what you can use to run your cells. So first of all, we'll start by how you can query data using quantopian.org and what kind of data you can get using Quantopian. So let me import the relevant libraries. So from quantopian.research, I'm going to import prices and symbols. Okay, so one thing is, what is prices, what are symbols? So these are functions inside the quantopian.research module. So symbols is going to is a 2-degree search function inside prices. So let me increase my font size a little so that you can view better. Okay, I hope it's the visibility is better now. So yeah, so inside the prices query, we are going to use the symbols function. So what exactly is this prices query is that the prices is a collection of real-time data from the stock market. It has the opening, closing, and high prices of various registered stocks, and we can query that data, real-time data, latest data. And getting the latest data from the stock market is a bliss nowadays in finance. So let me tell you how you can get this. So let me define a variable, which I'll call it Apple close. So AAPL is the official registered symbol of Apple, which is a software and mobile development and various hardware developments are done inside Apple. I am sure most of you are familiar with Apple. So we are going to query it using the prices function. Apple underscore close is going to contain the prices for Apple, the closing prices for Apple day wise. So what are the arguments inside this prices function? The first argument is assets. So this assets is going to take the symbol of which company I want the data to be. So I want Apple data. So I'm going to give it A, P, and L inside my symbols. And hopefully this query is going to generate the data for me. The next argument is the start date. At what date do I want to start? And in Quantopian, the start dates are actually they're in the YYY format. So first of all, you have to give the year. Let's say I want the data to be from 2014. And let's say I want the data to be from the 1st of January of 2014. So this is going to be the starting date for my data and the ending date for the data. Till what date do you want the data to be? So today is 2018 and it's the 20th of December. So let me get the data. Let's see if I can get the data till the 19th of December. That is yesterday. Now let's just make a small change. This L has to be capital and rest all looks fine. So my query is ready. As you can see, the first degree query function that I have used is prices. Inside prices, to query the symbols, I have used the symbol function, and hopefully I will get my data inside prices. Okay, I have made a spelling mistake. It's not symbol, it's symbols. So my kernel is running. Let us see. So since it's a lot of data, it takes a bit of time. Okay, my data is ready. Let me have a look. Okay, so this is also this is just like a Jupyter notebook. Whatever last line is written on a particular cell, that is printed on as the output. So you can see that the name of the equity is AAPL and the data is of float 64 format, and I am able to get the data till the 19th of January 2018. Mind you, today is the 20th of January on 2018. So this is the latest data till yesterday, and as soon as the market closes today, it's real time connected to the market. So the closing price for today will also be available tomorrow. Okay, so let's see what all computations I can do with it. So whenever you have a financial data, to analyze the data, you would like to have a moving average of the stock price, because stock prices can surge on a few days based on some market news, based on merger acquisitions, based on newspaper articles, based on buzz, a lot of things. So you want a moving average to know how good a stock is or how bad a stock is. So the Quantopian research environment will provide you this opportunity to this facility to get the moving average. So this is called the simple moving average. And how we calculate the moving average? Let me put that formula on my notepad. Simple moving average. SMA. This is the short form of simple moving average in financial literature. Take the data for the latest end days, sum it, and divide by. So to calculate the simple moving average with respect to n day time, you take the data for the latest n days, sum it, and divide it by n. So if I'm taking the simple moving average of closing prices today, let's say I'm taking a moving average with respect to 10 days, then if I take the same simple moving average tomorrow, I have to exclude the last day and get the data for the next day. So this is how it works. You have to take the latest n days and divide it by n. So you exclude one quantity every time for the next day, and you include the quantity of the latest day. So this moving average, it moves over the whole graph of your stock prices. That is why it is called the simple moving average. And since it's the simple average, and hence the word simple. So let me get back to my Quantopian research notebook. and show you how we can calculate the simple moving average. So we'll calculate one or two simple moving averages and plot a graph of them and see how it works. So the simple moving average function, what it is going to take is the first argument has to be the quantity of which you want the average. So this should be a series, an array, a list or tuple, something like that. So here I have stored my data in apple underscore close. So I'm going to take this apple underscore close, and then I have to use the rolling means function. So rolling, and inside this rolling, I'll give the number of days. Let's say I want 20 days, and I'm going to take the mean. So this is the rolling function. It is going to take the latest 20 days of data for me, and the mean function will do the mean. So this is a kind of a brute force method which I have applied to get the simple moving average using the rolling function. And as the session progresses, we may find time to get the exact data, the exact function in one shot, which can calculate a simple moving average for us. Let's see. Let's calculate another simple moving average. And let's say this time for 60 days, I want this. Let me just copy this line, and I'll just replace 20 by 60 to get another simple moving average. And so I'm able to get a simple moving average, two simple moving averages. Hopefully will be there when I run this set. Now I'll also import pandas as PD. Pandas is a popular library for data science in Python. I'll import pandas as PD so that I can view this data in the form of a data frame. Now what I want to do is I want to convert the simple moving averages and the closing price data that I have got. I want to convert it into a data frame. So how can I convert this data into a data frame is that I can actually pass this pd.dataframe function. I can pass this a dictionary. So a dictionary in Python is like a hash map or a hash table in Java, C++. So it contains key value pairs. So I'm going to give the Apple closing prices as the key, and the values they're going to be okay for the key. It's a string. So yeah. And the values are going to be apple underscore close, which are the closing prices for Apple. And let me give another key here. And this is going to be rolling mean or simple moving average, SMA 20 days. And this will contain ASMA underscore 20. And then I'm going to get, and then I'm going to give it my I'm going to give it the SMA for 50 days. So I'll name it SMA 50 days. And I'm going to give it the 60 days. I'm sorry, we took 60 days. So SMA for 60 days. I forgot the as here. I have to import pandas as PD. Okay, there has to be a closing bracket for the dictionary. Okay, so hopefully I have gotten my data frame. Let me save this data frame in df, a variable called df. And now let me view df, what df contains. So I have been able to get some closing prices for all the dates. And you'll see carefully that in the SMA for 20 days, first few values are missing. That is because unless you have the closing price data for 20 days, you can't have a rolling mean or a simple moving average. And in 60 days, more data is missing because unless you get 60 values, you can't have a rolling mean for that. So let me just plot this data and see what insights I can draw from this. So this is similar to a Python plot. So if you are familiar with the pandas library in Python, you should be comfortable with this plot. So I'm going pd.plot. This is going to plot all the variables for me with respect to their dates. And I can give a title to this plot here. So I'll give a title, Apple closing prices. And simple moving averages. Okay, I think I need to give a semicolon here. Okay, so what I can do is I can plot it from here itself. Wherever I have created this plot, let me just not save the data because my objective is to plot it. So I'm going to plot it. And let me give it a title here only so that I don't have to save my data elsewhere. It's giving me a security exception otherwise. So Apple closing prices and moving. Okay, so I don't have a security exception there, and you can see that I have got a nice plot for my closing prices and moving averages. So one thing to note in this plot is, let me increase my font size a little more. So you will see that the plot for SMA 20 days is green in color. So when you see this plot, you will see that this is actually not starting from the origin. It is starting from somewhere here. That means it is not taking the value for the first 20 days. And the plot for SMA 60 days is red in color. So it is not taking the value for the first 60 days. For the first 59 days, it is not going to have a value. As soon as the data for the 60th day is available, it is going to take the average of those 60 days. So this is a nice plot using the plt.plot function. I don't even need to give the grid to it, and I can get that. So this is one kind of data that we have queried using the prices function, and we have plotted that data. And we have seen that we are able to get the real-time data from the industry. So now let's move on to another query function. And this time, let me query the returns of a company. So from quantopian.research, I'm going to import returns. So this research, this returns function has now been imported, and this returns function this works similar to any other query function, just like prices. So that I don't have to give it again and again, let me just give a period start, and let's say it's 2013, and let's say 10. Let's say today's date 12 and 20, and let me give a period end here. So the period end I'm going to give is going to be from 2015, let's say, and the same date, 12 and 20. So I'm using this so that I don't have to give my starting and ending dates again and again. Now what I can do is, let's query the returns for Apple. So the returns that Apple is going to get, Apple underscore returns, and I'm going to use the returns query function to get the returns. And here what I'm going to do is, again, the assets is going to take the symbols, and I've already imported symbols, and let me give the symbol as Apple. And what else do I need? I need a period start and a period end. So start is going to be period start, and end is going to be period end. Okay, so let's see if I have actually gotten the returns data for Apple. Wow, so the returns data for Apple is available. So querying data is that easy in a Quantopian research environment. So this is what we call fundamental data in the finance industry, the data that is directly available from the stock market. But there can be different types of data, and one of the latest developments in the type of data is alternative data. What we mean by alternative data is that, let's say I'm talking about an oil drilling company. So the drop or fall or increase in the company's share prices is going to show much later. But first of all, the company's tankers are going to move. If I have the let's say the geolocation, I have the location, I have the data from satellites, then I can see that their tankers are moving. If the tankers are moving in heavy numbers, then I can predict that the stock is going to go up. I don't need to wait for fundamental data. So this kind of data that is received from the alternative sources is called as alternative data. It is not received directly from the stock market. So one such data that the Hackveda has been really interested in interviewing is the data for the messages that people leave about companies. And using those messages, today what project we are going to do is that using those messages, we are going to see what kind of correlation the message volume and the message sentiments they have on the company's returns. So we have already gotten Apple's returns. Now let us see how we can get alternative data from Quantopian, and how we can work with this alternative data and plot graphs to find the correlation, to visualize our correlation. So for that, I'm also going to introduce you to something called the pipeline API in Quantopian. So what this pipeline API is going to do is, actually, this is one interface that you see on your screens is one interface. But Quantopian has another interface where you can write algorithms to trade. Pipeline, it takes your data from this interface and connects it to the algorithm interface. So it takes your data from your research notebook and it connects you to your algorithm interface. That's what a pipeline is. So we are going to do this project. We are going to plot the graphs to find out the Twitter sentiments and how stock prices have varied with date and Twitter mention, probably on the same plot. Let's see how far we can go. Also, what we are going to do is we are going to in process learn how a pipeline works, what are the functions of a pipeline, and how to make a pipeline, what is the pipeline intent, and all of that. So let me just get started with it. So from Quantopian .research, let me import the run pipeline function. So I'll tell you more about the run pipeline function when we actually use it. This is the function which takes the data from your pipeline and it gives the data to your algorithm in the algorithm IDE from Quantopian. And there are going to be other functions from Quantopian .pipeline. We're going to import this API, the pipeline API. So please be careful. This research notebooks are they're case sensitive. So you have to make the P capital here for pipeline API, and for all other usages of pipeline, run pipeline, make pipeline, etc. The P will be will continue to remain small. So from Quantopian .research pipeline. Okay, I made a spelling error here. From Quantopian.pipeline.factors. So this is multiple classes that inside the Quantopian module, there is another module called pipeline, and inside pipeline, there is another module called factors. So from factors, we are going to import returns. And then from Quantopian.research, sorry, Quantopian.pipeline is needed here. So from Quantopian.pipeline, we are going to get the data that we want. So we want the data for the Twitter sentiments and the messages that were received for Twitter for a company. So where this data is exactly present is that this data is inside the psych signal. So PSYCHSIG and MAL. From this psych signal database, we are going to import stock tweets. Let's see if all these imports are successful. Okay, I think I missed a dot here. Okay, so all this data, all these required modules are now available with us. So let me guide you how to build a pipeline. So whenever you are making a pipeline, you have to make this pipeline inside a function. I'll let you know why. Because whenever you're trying to get the output from your pipeline, you have to pass it an intent. That intent is created inside the function where you make your pipeline. So we'll make our pipeline inside a, let's say, make pipeline function. We're going to use this function, and this function is for now going to take no arguments. Okay, so you have to put a colon in Python whenever you are defining a function. You have to add a colon. This is a part of Python syntax, and anything inside in this indentation is going to be a part of the make pipeline function. So let me now use my query functions to get the returns for a company. And to this returns query function, I'm going to just note that this returns query function, now I have gotten it from quantopian.pipeline and not from quantopian.research. So this research function, returns function works a little differently. It is not going to take your starting and ending dates, but what it is going to take is, because starting and ending dates you have to define inside your pipeline only. So inside this returns function, what you have to give is you have to give the window length. Let's say I want to give a window length of 2. So the meaning of window length is that from which day's closing price will it subtract the next day's opening price to get the returns. So I just want it to be consecutive days. So I'm taking a window length as 2. You can try with window length 3 or 4 or etc. If you want if you want a return for 2 days or 3 days or 4 days. So this is the meaning of window length. Okay. So now what kind of sentiment do I want? First, I wanted to have a sentiment. I wanted to plot 3 tasks to complete this project of data visualization. So I want a sentiment of bull minus bear. What is a bull and what is a bear? Let me explain it to you. Whenever in finance, in the stock market, whenever a high price is achieved by a stock, we call this as a bull, because if you look at a bull's pace is pointing upwards. So that's why it's called a bull. If you ever happen to visit the Wall Street, they have a picture of a bull over there, because bull signifies profit, bull signifies higher margins of business. And we are also going to get the bear. Bear is when a stock hits a low. So I want the sentiment of bull minus bear, which I'm going to get from my stock tweets database that I have imported. It has a column for bull minus bear, which is the quantity that I'm interested in. To know how good or bad a stock is, I want to have a bull minus bear. So mind you, the stock tweets, this is going to be a 3-dimensional database. First of all, there is stock tweets. Second, I want to get the columns for bull minus bear. Now, bull minus bear are arranged in a 3-dimensional pattern inside the Quantopian. So whether I want it, which time frame I want it, I have to specify that. So because at Hackveda, we work with latest things. The Quantopian is latest, the data is latest, and this data, the sentiment data is again going to be latest. So let me get the latest data. So sentiments keep updating themselves. That is why they have to make a 3-dimensional kind of a data structure to accommodate these. And let me also get the message volume, because sentiments is okay, but at what message volume I have got those sentiments, how many people have those kind of sentiments is extremely important for us. So let me get that also from stock tweets. Again, I am going to take the total scanned messages. Again, the messages are going to update themselves, so we are going to put them in a so they have them in a 3-dimensional data structure, and we are going to use it. So again, we are going to get the latest messages. Now, this make pipeline function is going to return our pipeline. Again, the P for pipeline has to be capital. So what is going to be inside our pipeline is that we will have to have columns inside our pipeline. So this is going to take columns, and again, inside the columns, we have to pass it a dictionary. So inside dictionary, since I have taken window length 2, I'll say these are daily returns. It is going to subtract it from the next day's, the previous day's opening price, the closing price is going to be subtracted from the next day's closing price. So this is the daily returns. And what are my daily returns? I have stored them in a variable called returns. So that is there. And then the next thing that I have is that I have my sentiments. So let me store it as sentiments only, sentiment, and inside this I'll give it a variable sentiment. Okay, let me give a comma here. All right, and then we are also going to give it the message volume. At what message volume we have got? We have queried it from our 3-dimensional database, and we are going to use it message volume. And so hopefully this is going to be it for my database, and let's run this make pipeline function. So this make pipeline function seems to be working fine, and we are able to get our pipeline for the data that we have asked for. Now how we are going to take this data as an output inside the same function. If I want to get this data in the form of a pipeline, how am I going to get this output? This is using the run pipeline function. Okay. The run pipeline function, which we have imported from quantopian.research. We have imported the run pipeline function here. So we are going to use this function to query our data, and to query our data inside the same research notebook and not in the algorithm IDE. So this is going to take an intent. Intent is a reference to self, and make pipeline, as soon as we have created this make pipeline function, it has judged that we are returning a pipeline, and so the name of the make pipeline function is going to be enough for an intent inside this. It is also going to take the start date. Now it is going to take the start date. So a pipeline doesn't contain start date or end date. So that is important. Why? Because a pipeline's final objective is to get integrated with the algorithm API. Since your algorithm is going to work daily, there are no starting ending dates defined for your algorithm. It is going to make trades daily. So that is why there are no start dates or end dates inside your pipeline. But when you are querying, of course, you will provide the start date and end date. So let me give you just a start date as period_start that we have defined earlier. And also this is going to be an end date. So let me define the end date as period_end that we have defined earlier. So let me see if this works. Querying data is going to take some time, and as you can see, my kernel is busy. So let's just go up and check if the dates were correct. Period start and period end. Yes, right. So the kernel is going to be busy for a while. Okay, so I've got my data inside the data output. Let me just have a look. Okay, wow. So I'm going to get my data in this format. I've gotten the stock name and the equity name, the daily returns. So you can see this time we have not taken the data for Apple. We have taken all the data that is present inside our stock tools database for all the companies. So we will see very shortly how we can query that data. But okay, we have got the data. Now let's see how we can query the data for Apple. Let's say I want the data for Apple. Apple is my favorite company. So I'll have the data for Apple, all the data for Apple. So, okay, from this data output, I'm going to query using .access. And to this .access, I'm going to pass this symbol, the symbols for which I have to query. And the symbol is Apple. Let me put it in single quotes, AAPL. Okay. So I have made a query for the Apple symbol, and I want the data to be of level 1. Level 1, what it is exactly means is that I want my data to be, I have three types of data. So I don't want my data to get merged with each other. I want each data separately at one level. So the level I'm going to give is 1. And let's see if I can query this data and I can plot some some graphs out of this data. All right. Okay. So looks like I have been able to plot to get this data just for Apple, and this time what we are going to do is that let's see if we can plot this graph for this data. Apple output, let's see what kind of output we have got first. Okay, so we've been able to get the output for daily returns, message volume, and sentiments from our set start dates and end dates. Good. Now let me plot the graphs for this data, and from these graphs I can get my insights. I'm going to put subplots equal to true, so that I don't get it on the same graph, but with the same axis I'll get it on different graphs. So I'll plot true here, and okay, I'm sorry, I've given the data as apple underscore plot. It should be apple underscore output. So apple underscore output. All right, so we have got three very beautiful graphs, and we have been now we can draw insights from these graphs. Let's see. The first graph is for daily returns, the second graph is for message volume, the third graph is for sentiments. So as we see here that let's say around, okay, let's say when was the message volume very high and the sentiment was also distinct. Okay, let's see at around this point. Let's see, this should be between May and June 2015. I'm seeing that the sentiment score is here. It is close to minus 0.3. I have a negative sentiment score, and the message volume is also very high, and thus I'm getting a loss on my daily returns. My daily returns are also negative in this period. So I can find certain, through this project, what I can do is I can find certain special dates where wherever my something special has happened. Whenever, let's say if the message volume is very high on this particular day, then I can go back and check. Most probably the company has announced some merger and acquisition, or the company is in the homeland of the company there's been a change of government or something like that. So this kind of analysis in finance is what we call the hindsight analysis. Analyzing things in the hindsight from alternative data. And if we are good on our hindsight analysis, then obviously we are going to be pretty good with our foresight analysis as well. So the next time around when we see that the message volumes is very high, then we can interpret what the behavior of the stock price is going to be. Or the next time if we find out that a company announces a merger and acquisition, then we can interpret that the stock price is going to take a hit or is it going to go up using the previous data. So this kind of graph, this kind of projects help us, and it is only through these latest tools that we are able to get connected to real-time data from sentiments for stock prices, etc. So now let us change a bit in our pipeline. Let us make a small change in our pipeline. So what I'm planning is that wherever I have done these imports, I want to import I want to screen my pipeline. I want only some particular data from my pipeline. How I can do that? So what I'm going to do is that from Quantopian dot pipeline dot data, I'm going to import some more data. Let's say I'm going to import the US equity pricing. Let's see the data for US equity. So I'm going to get this data, and from Quantopian dot pipeline and dot experimental, I'm going to import Q tradable stocks in the US. Okay, so the syntax looks just fine. Okay, Q, I think T is to be capital. Okay, so there is some error. Stocks in the US. Okay, there seems to be some spelling error here. Okay, let me just check on the internet what kind of Q tradable stocks US on Quantopian. Okay, I'll get back with my screen once I have the list of Q tradable stocks in the United States and what the exact syntax for that is. Let me get inside my directory and let me check for the stocks that are there, the stock name. Okay. Okay, so we were here and we want to check the documentation for Quantopian for the Q tradable stocks US. Let me just check my spelling. I think I have missed a capital S here. That is the reason. Okay. Let me just copy this. I think this is the correct one. Okay, so there must have been some spelling error, but that spelling error has now been rectified for the Q tradable stocks US, and I'm able to get that now. Yeah. Okay. So I've got the data for the Q tradable stocks in US. That means whatever stocks in the US stock exchange in the NYSE for trade from Quantopian. That's the list of those stocks. And now I'm going to tell you how you can make your pipeline and screen your stocks at the same time. And then we are going to end this session here. So let me check. Let's say base universe. I'm defining a base universe. And that base universe I'm going to say is the Q tradable stocks US. Whichever stocks in US are okay, so they can be traded through Quantopian, and then I'm also going to have the list of closing prices of the equities of these stocks, and how I'm going to get this is again through my three-dimensional data set. Let's say this is the US equity pricing data set. From this data set, I'm going to get the closing prices. Again, it's a three-dimensional data set, rows, columns, and whether you want the latest or not. So I want the latest. I have chosen to be the latest. And now I'm going to get the sentiment score also. Again, the sentiments for this time, let's have a let's say I want to have the same sentiment score, and and what I can do is that maybe I can mm, yeah. So what I can do is that I can have a different sentiment score this time. Let's say I'll okay. I'll also show you how to use the simple moving average function from inside Quantopian. So what I can do is that from Quantopian from the Quantopian pipeline factors, I'm going to import the simple moving average. So Quantopian dot the pipeline dot factors. I'm going to import the simple moving average. And let's say if this gets successfully imported, I think the cell has been done. Yeah. So I have been able to get this cell, and the sentiment score that I would now want is, let's say I don't want the bull minus bear. Now I want a different sentiment score. So this time, what sentiment score I'm looking for is, let's say I'm going to look for the simple moving average. And inside the simple moving average function, I have to give it for what value you want the moving average. So let's say I want the moving average of my stock twits, and from the stock twits, I want the bull minus bear, bull underscore minus underscore bear, and from this bull minus bear, the inputs have been given. So I'll just equal to here. So I'm giving a keyword argument, and for what time I want the moving average to be. So the window length that I'm going to give here is going to be 4 days. Let's say I want the moving average for 4 days, and so what this is going to do is that, let's say I have reached here. Let's say I will not call it daily returns, but I'll call it close price. I'll call it close price, and here I'm going to call it I'm going to call it the close price as well. So I've gotten the close price, I've gotten the sentiments, and the message volume also I've been able to get. And so what I'm going to do to screen is that after the comma that I have placed here, I'm going to give it another argument called screen. So what the screen is going to do is that it is going to screen my base universe, the base universe that I have provided. Okay. So let us run this cell again. Okay, have I changed the name? Okay, I have given the name sentiment score. So let me just change this to sentiment score. And now let me query my pipeline. Okay, let's I think I have to add this here inside my base universe. One more bracket. Okay. Okay, so I have decided given it my Q tradable stocks US, but I have not marked this bracket over here. That is why it is giving me the error that it has actually got a function instead of values. This Q tradable stocks US, you have to call that function. You can't give the name of that function. So hopefully now in some time I should get my data output. So this is going to take some time because querying data, as we saw last time also, querying data would take some time. So we will wait until this data gets queried. Okay, so the data that we wanted to query has now gotten queried. So let me just run it in a different cell. So data underscore output. Okay, great. So I have again gotten my data, and this is how you can double query your data. You can screen your data from a huge database of all the equity prices in the US. You have now using in your pipeline, you have been able to screen it. You have been able to screen it for your base universe. Inside this base universe, you can give your conditional operators like and or. These conditional operators can also work inside your base universe in Python. These are simple Python syntaxes. You can write A and D, or you can write and like this. And if you want to give any other universe also, base universe 1 and base universe 2, if you want to have two base universes, and if you want to get the intersection, then you can provide them with an or option. Or if you want your data to be present inside, if you want your data to be present inside both the databases, then you can give it an keyword, and you can provide the name of the next database over here. So this is how you query your data, and this is how you plot graphs using Quantopian. And so pretty much this is a introduction to how you can use the Quantopian to get your latest databases from the stock market. You can plot graphs, how you can make pipelines, how you can extract data from the pipelines, and how you can query data inside your pipeline using the screen attribute. And how this concept of three-dimensional databases works inside Quantopian. So this presentation on Quant Finance was brought to you by Hackveda, and I request you to visit hackveda.in, our website. And so there you're sure to find many interesting things. If you are interested in Quant Finance, you're sure to find some great resources over here at Hackveda. So please use this talk to mentor option if you want to talk to me, if you have any suggestions, if you have any doubts or queries. Please feel free to talk to me on the talk to mentor option present on our website. Please keep visiting www.hackveda.in. Please visit our Facebook page, subscribe to our YouTube channel, because we are going to bring you the content, the latest content that is there in the market for financial machine learning. So if you're interested in financial data science, if you're interested in finance data is going to be your way ahead. And I'm Divyam Sharma, finance machine learning intern at Hackveda, and I'll sign off. Please feel free to talk to me on the talk to mentor option at www.hackveda.in. Thanks for being with us. Thank you so much.